To solve the given radical equations that contain one radical, we want to first isolate the radical on one side of the equation. Then we're going to raise both sides of the equation to the power of the index. This will undo the radical, and then we'll solve the resulting equation. And when solving radical equations, it's very important that we check our solutions, because sometimes we'll have extraneous solutions or solutions that don't work. So for our first example, we want to isolate the square root of x. So to undo this minus 1, we'll add 1 to both sides of the equation. This would be 0, leaving us with the square root of x equals 5. Now we want to undo the square root by raising both sides of the equation to the power of the index. And since the square root has an index of 2, we're going to square both sides of the equation. Again, the reason to do this is, if we square a square root, this will simplify to just a radicand. The square root and the squaring undo each other. So we have x equals 25. Now let's go ahead and check our solution in the original equation. If we substitute 25 for x, we would have the square root of 25 minus 1 equals 4. And the square root of 25 is 5, and 5 minus 1 does equal 4, so it checks. Let's take a look at our second example. In this equation, notice how the square root is already isolated on the left side of the equation. And again, because it's a square root and the index is 2, we're going to square both sides of the equation. So the square root of x plus 8 squared simplifies to just x plus 8. And on the right side, we have 2 squared, which is equal to 4. And now to solve for x, we'll subtract 8 on both sides. This is 0, so we have x equals negative 4. Now let's go ahead and check our solution. We'll substitute negative 4 for x into the original equation. So we'd have the square root of negative 4 plus 8 equals 2. Well, negative 4 plus 8 is equal to 4, and the square root of 4 is equal to 2. Therefore, our solution checks. We'll look at several more examples in the next few videos.